Okay, second unit is a transportation problem. So this transportation problem is also one of the application of linear programming. In case of transportation problem, the various resources will be transported from one location to another location. So here, as I have written, in case of transportation problem, the various resources or items will be transported from set of supply points to set of demand points where the items are actually required or actually demanded. So let us understand this with a simple network, with a simple example or with a simple network. So here, as you can see, there are various supply points where the resources are actually available, and there are various demand points where the resources are actually demanded or required. So here we have three supply points, S1, S2, S3, and the various units that are available at these supply points are 40, 25, and 35. And here we have various demand points D1, D2, D3, and the various resources, okay, the various quantities of resources required at these points are 30, 30, and 40. And we can transfer the items from supply point 1 to demand point 1, or from supply point 1 to various demand points. As you can see, from S1, from supply point S1 to all these three demand points, the items are being transmitted. Here also, from supply point S2 to here also, that various items are transmitted from supply point S2 to various demand points. Yeah, from supply point S3 also, the item is being transmitted from all these three demand points. And here we don't know in what quantity the item is being transmitted. So what we do here, we assume that quantity as Xij. Okay, here since we don't know in what quantities the items are being transmitted, hence we assume that as Xij, where I takes a value from 1 to 3. Why? Because we have three supply points, and hence I takes a value from 1 to 3. And also J also takes a value from 1 to 3, because we have a three demand points. So let Xij be the quantity that is being transmitted from one end to the other end. So here, okay, here this quantity we don't know, we write it as X11. Okay, this quantity here we write it as X12, and this quantity also we write it as X13. From the supply point 2, we write it as X21. Here also we write as X22, and here also we write it as X23. And from supply point S3, here also we don't know in what quantities we are transmitting, we consider it as X31, X32, again here X33. So totally we have 9 unknown quantities, and every quantity that is being transmitted from S1 to D1, or S1 to D2, or S1 to D3 will involve some amount of cost. Say we are transmitting some quantity X11 from S1 to D1, which has a cost 8. Again, here also we are transmitting X12 quantity from S1 to D2, which involves a cost of 9. Here also we are transmitting a quantity X13 from here also we are transmitting a quantity X13 from S1 to D3, which has a cost of 7. So in the same way, all other quantities, that is X21, X22, X23, X31, X32, X33 will have a cost associated with it. So how do we represent this cost? Means Cij. Okay, the cost is represented by Cij. So this is C11, this 8 is C11, this 9 is C12, 7 it is C13. again this 4 is C 2 1 3, this 3 is C 2 2 5, C 2 3 8, C 3 1 5, C 3 2, again 6 3 C 3 3. So these are the various costs associated with these quantities that is being transmitted from various supply points to various demand points. So here the problem is how to transmit a supply of 40, how to transmit a supply of 40, 25, 35 to meet the demands of 30, 30, 40, such that the total cost of transportation is minimized. So that is why in this case the objective function is of minimization type. So here the objective function z is equal to 8x11 plus 9x12 plus 7x13 plus 4x21 plus 3x22 plus 5x23 plus 8x31 plus 8x3 plus 5x32 plus 6x33. And we have two constraints for supply as well as for demand. What is the constraint for this supply means xij, summation xij should be less than or equal to ai. Okay, where ai represents the supply. So what is the constraint for supply means summation xij less than or equal to ai. This ai represents the supply. Again, what is the constraint for demand means summation x ij should be greater than or equal to bj. Again, this bj represents demand. So here we have various values. Okay, for AI, we have various values for AI. Say here the A1, the value of A1 it is 40, A2 it is 25, A3 it is 35, and again various values for BJ. B1 it is 30, B2 it is 30, B3 it is 40. So what is this supply constraint means the values, okay, the quantities that are going out from this S1 should be less than or equal to 40. Say that is X11. That is what summation, right? X11 plus X12 plus X13 should be less than or equal to 40. That is the first supply constraint. And the second supply constraint is X21 plus X22 plus X23 should be less than or equal to 25. And that is the second supply constraint. And the third supply constraint is X31 plus X32 plus X33 should be less than or equal to 35. That is the supply constraint. And what is the demand constraint? Okay, demand constraint means the various quantities that are coming towards this D1 point should be greater than or equal to this demand, that is 30. Say what are the various quantities coming towards this demand point? So to this demand point X11, okay, X11 plus X21 plus X31. It should be either equal to this 30 or it can be greater than 30. That is the first demand constraint and the second demand constraint. So what are the various quantities that are coming towards this D2? So it is X12 plus X22 plus X32. It should be greater than or equal to 30. And again, that is the second demand constraint. What is the third demand constraint? Third demand constraint is X13 plus X23 plus X33. It should be greater than or equal to D3. D3 or 40. And as you can see here, we have M supply points and N demand points. So the number of variables required here, it is xij is equal to m into n. So m is 3, n is 3. So totally we have 9 variables. And how many constraints are required means m plus n. So here we have 6 constraints. Okay, so 3 constraints for supply and 3 constraints for demand. And this transportation problem is said to be balanced okay, what are the example here we have taken? It is said to be a balanced transportation problem. Why? Because this summation, okay, this summation of ai is equal to summation of bj. See, if you add these quantities, it is 40, 25, 35, which is equal to 100. Again 35, 30, 40, which is equal to 100. In this problem, since supply is equal to demand, this is an example for balanced transportation problem. Okay, when we have a when the supply is equal to demand, we can actually replace these two, the inequalities that is present in these two constraints. So we can actually replace this as equals. Again, even this can be replaced as equals.